Hello, everybody. Have you ever wondered if your phone could double as a physics lab? Well, with an app called Phyphox, it can. Today, I'm going to show you how this app works, its features, and how it lets you explore physics concepts like acceleration and motion with just a smartphone. Phyphox, which stands for Physical Phone Experiments, is an app developed by the RWTH Aachen University. It turns your smartphone into a portable physics lab by using the built-in sensors of your phone, like the accelerometer, gyroscope, and magnetometer. It's perfect for students, teachers, and anyone who's trying to do science. It allows you to conduct physical experiments without the need for expensive lab equipment. It has a ton of uses, it's very versatile, it's interactive, and it gives you real-time data visualization. Whether you're studying motion, sound, or magnetism, it's got lots of different uses. All right, let's take a quick look at some of the features that it offers. So it has a ton of different pre-built experiments. Like as you can see here, you can add experiments from a QR code, or you can add simple experiments, which it has a bunch of. It usually just offers you its active sensors like the accelerometer, linear acceleration, and a lot more. It also has real-time graphing, as you can see here in the previous experiments I've taken. It has about 10 seconds, 20 seconds of data over it, and it has it for the linear acceleration on the y-axis, x-axis, and z-axis. And that's what you get from using the accelerometer specifically. It also has a lot of different customizable parameters. Like, for example, if you use the pendulum, you can decide your length and you can change everything like this. And you can, as you can see, you can switch it here, make it 100 centimeters, 50, whatever you want to do. And once you start swinging it, you can see exactly what happens. Here, I can demonstrate really quick. As you swing it back and forth, you see the different axes, and how they change, which kind of detects the rotational motion, which is useful for things like pendulum swings and stuff like that. And it utilizes a couple main sensors from your phone: the acceleration, which measures motion or forces along 3 axes, the X, Y, and Z axis, the gyroscope, like I just explained, and the microphone, which can capture sound waves for intensity or frequency analysis. Like here, you can choose your frequency. Once you speak, it'll change, and there's a bunch of different uses for that. There's so many different use cases that I can't go over all of them in this video. Go over the accelerometer specifically. So the accelerometer involves itself in these 2 scenarios specifically that I'm going to look at. 1, the acceleration without gravity, and 2, the acceleration with gravity. I'll be doing experiments with both of these. One experiment without gravity, where I'll be sliding my phone across the table and seeing the acceleration in the X, Y, and Z directions. Then I'll do an experiment the same way, sliding my phone across the table and seeing the acceleration in the X, Y, and Z axis. Finally, I'll be tilting my phone in place in my hand, and I'll see the similar X, Y, and Z accelerations. And so how the accelerometer works is that it doesn't actually know what's going on around it. It just knows the forces that it's experiencing on it, as well as it knows what gravity is. So it assumes, in the scenario with gravity, it assumes that 9.8 at free fall, it should be experiencing 0 force, as gravity is just a constant. Therefore, as someone who is holding the phone, there is 9.8 meters per second of acceleration going up on the phone, as you'll see right here. As you can see, it's right around 10, and the other 2 stay constant. Now I'll be looking at the acceleration without gravity. How the accelerometer works for this is it doesn't track gravity as a force. Therefore, when it is in free fall, it's actually going down in the z direction at 9.8 meters per second. Therefore, when I'm holding my phone as I'm doing now, it is experiencing 0 force in the z direction, and it should be experiencing z in the x and y as I'm holding it relatively still. This is because there is no gravity force down that's assumed, and therefore the normal force of my hand pushing up on it is assumed to be zero, as those two cancel perfectly out. You can see this right now. It says around 0.2 for each one, and that's just due to human error. In our first experiment, we'll be looking at acceleration without gravity. In this experiment, I slid my phone across the table with the acceleration without gravity feature turned on. This means that the phone will be experiencing no forces when it is lying flat on the table. Compared to with gravity, it would be experiencing 9.8 meters per second upwards due to the normal force. Because of this, the phone should only experience acceleration in the y direction going forward and possibly the x direction going side to side. However, it experiences slight force in the acceleration in the z direction as I push down on the phone when I begin sliding it. This also means that it oscillates back to negative 10 meters per second after I push down on it. Now I'll be looking at the acceleration without gravity. How the accelerometer works for this is it doesn't track gravity as a force. Therefore, when it is in free fall, it's actually going down in the z direction at 9.8 meters per second. Therefore, when I'm holding my phone as I'm doing now, it is experiencing zero force in the z direction, and it should be experiencing z in the x and y as I'm holding it relatively still. This is because there is no gravity force down that's assumed, and therefore the normal force of my hand pushing up on it is assumed to be zero, as those two cancel perfectly out. You can see this right now. It says around 0.2 for each one, and that's just due to human error. As compared to the previous experiment of acceleration without gravity when the phone slides across the table, I will now be exampling acceleration with gravity as the phone slides across the table. This means that the phone experiences no force when it is in free fall. Therefore, when it is lying flat on the table, it experiences 9.8 meters per second of acceleration from the normal force of the table. And this is in the z direction, since the phone is tilted as if going upwards and downwards is the z direction, forwards and backwards is the y direction, and side to side on your phone is the x direction. This is why you can see in this recording the phone acceleration on the z direction varies from 0 meters per second to 20 meters per second. As when I press down, it goes down to 0 meters per second, and that takes it down from the 9.8. And then it goes back up to 20 meters per second as it oscillates the 10 meters per second of force I push down with the 10 meters per second the table is pushing up, leading to 20 meters per second. It also experiences similar acceleration in the y and x directions, as those haven't changed. Unfortunately, I didn't have time to go into the tilting aspect of the accelerometer when acceleration without gravity is tracked. So I'll go into the pros and cons of this app. One con I found of this app is that when you collect some data, as I'm doing now, and you finish collecting it and you try to exit out, it totally gets rid of your data, sometimes without telling you. Another problem with this app is that after collecting some data, when you try to make a graph of it to see the different accelerations at each time, you can export the data, but there's no way to actually graph it on the actual app, which makes it more complicated. You have to use an Excel or a CSV file, which are quite complicated, or they're not that complicated to use, but it's definitely extra work. Despite the drawbacks I just described, there's a lot to love about Phyphox. It's completely free, works on almost any smartphone, and it requires no additional equipment, so it's super useful for students and educators. It has a wide variety of experiments from magnetism to motion to sound waves to gyroscopes, so it's a valuable tool for exploring a lot of different areas of physics. Almost every project we've done this year, from our density experiments to our rolling a cart down a ramp, could be done with this app. It's super customizable, where it gives you recommendations for certain experiments you could do, and you can also tweak parameters, as I showed earlier, where you can change the length of your pendulum and stuff like that. And overall, it just is a very powerful tool that brings physics to life with just your phone. And it takes advantage of a lot of these built-in features like the accelerometer, and it allows you to perform interactive experiments that are educational, and you don't need the expensive lab equipment, as I mentioned. Overall, I recommend giving Phyphox a try. Whether you're a student, a teacher, or just someone who loves experimenting, this app is something for everyone. Thanks for watching.